In this example, the engineering team has been challenged with increasing the life of the blades and the other components in this reciprocating saw, as well as maintaining customer satisfaction. With moving components, there is always a concern for excessive vibration. This initiative will ultimately reduce warranty issues for the replacement parts, or in some cases, the entire product. Collaboration is paramount to making proper design decisions and getting the product to manufacturing on time. Other team members can benefit with the ability to view, mark up, and communicate their ideas from any location in a web interface. Designers can then reply to others and take action on comments right in the design environment. And all communication is saved within the file for future use. No more sifting through email to find notes on a project. In this case, we will analyze the possibility that the internal components may shake too much using a frequency study. The only components we are interested in are the gear housing and the two gear covers. Now let's begin by describing how the parts are held down. There are a few holes in the back where the motor is fastened. The motor is fairly snug in the outer housing or the body of the saw. Then we will also add the same type of pin constraint here where the flange is attached to the body as well. There is even the ability to observe part color for determining whether the components are held down properly and avoid free body motion. We can see the two covers shown in red are free to move. Contact conditions between these parts can be applied automatically, saving the time it would take to normally select the faces. Now that the analysis is set up, let's run the solver, which takes less than a minute to complete. It looks like the end of the gear housing will resonate at a low frequency of 124 Hz. Notice the animation provides great insight for understanding the behavior of the geometry and for determining a solution to the problem. Let's use plastic tabs on the outer housing to suppress the motion perpendicular to the selected faces. And run the solver again. Once again, we will animate the behavior and find the center of the gear housing has a tendency to move at 350 Hz. It looks like another change to the design is required to solve this problem. As mentioned earlier, collaboration with other team members will help to get the job done quickly. Let's take a look at a live review between the designer and engineering manager. This level of communication is unmatched with the ability to chat and even observe the changes being made to the design during the live review session. Gain insight from others who are working on the project or the customer using anything from a desktop computer to a mobile device. Discuss ideas and find out if they will work without reserving a conference room or the need for online meeting applications. In this case, we observed a plan to create ribs and connect them to the outer housing. Now the moment of truth. Let's test it using the study we have been working on. From here, we can simulate the connection between the two components. The first question is whether the design is going to improve our frequency results. Secondly, we also want to consider the additional cost in manufacturing when modifying the design. Connect the dots and ensure we are making proper design decisions. We can do this by measuring the impact of the change. Do the results meet our engineering criteria? After running the solver, it looks like we have reached our goal of close to 1000 Hz. We have significantly reduced the vibration on the gear housing, which in turn will reduce warranty issues on the product and increase customer satisfaction. As you can see here, a report can be created automatically displaying the setup and the results for the analysis. This includes frequency levels for mode shapes as well as mass participation factor. It can then be saved and sent to anyone for review. Autodesk Fusion 360 is more than a 3D modeling tool. Test your designs beyond linear static loading conditions, and collaborate with other team members or customers live and get the job done faster. There is no better way to ensure a quality design that satisfies engineering criteria and customer needs. Fusion 360 is your trusted solution. It is the future of making things.